This is the first video lecture for section 2.7 on apportionment. In this lecture, I'll be talking about the apportionment problem. So in the US Senate, we have 100 members, and that's 2 for each of the 50 states. But in the House of Representatives, states are represented based on population. States with higher population have more representatives, and states with lower population have fewer representatives. And the number of representatives gets recalculated every 10 years after the census that counts how many people live in each state. So for example, in 2010, the population of Pennsylvania was 12.7 million people, and it was calculated that Pennsylvania would get 18 representatives in the US House. And in that same year, the population of the state of Maine was 1.3 million people, and Maine had 2 representatives in the US House. So we have 435 members in the US House divided unequally, right, divided based on population among those 50 states. And so the apportionment problem is to figure out how do we do that? How do we figure out how many seats each state gets? That's the apportionment problem. So the basic idea is to determine what percentage of the total population each state has and give that percentage of the total number of seats to each state. That sounds pretty reasonable, but it turns out that that's a little bit too simple. And let's understand why by working through a couple of examples. So let's say we have a fictional country, just to keep things easy. Let's say that we only have 4 states, and let's say that we have 50 seats to divide among those 4 states. Okay, so according to what we said before, we're going to find the percentage of the total population that each state has. So the way that we're going to do that is we're going to take the percentage population is the population of the state divided by the total population. So in this case, we've added up the total population is 200,000. And so let's find the percentage population for state A here. So the percentage population would be the 80,000 divided by 200,000. And I'm going to type that on my calculator. So I've got 80,000 divided by 200,000. And when I do that, I get 0.4. Now, when we want to convert a decimal to a percentage, we're going to take that decimal point and move it to the right 2 spaces. And any empty spaces we fill in with zeros, and so that would be 40%. So we're just going to do that for every state. So we figured out that state A has 40% of the population. State B, again, what we're going to do is we're going to figure out 60,000, in this case, divided by 200,000. That's going to work out to be 0.3, which is the same as 30%. Again, what you do is you take that decimal point and move it 2 spaces to the right, filling in zeros for any empty spots. And so that's going to give me 30%. Similarly, in the same way, state C has 20% and state D has 10% of the population. And just as a double check, if I add up those percentages, I do indeed end up with 100%. Okay, so now what's the fair share? So the fair share is that same percentage of the total number of seats. We've got 50 seats in our legislature that we're trying to fill up, so we're going to compute that percentage of that number of seats. So the 40% for state A, we're going to take that 0.4, remember 40% and 0.4 are the same thing, and we're going to multiply that by the 50 seats, and that's going to give us 20. So that means that state A should get 20 seats in our fictional legislature. 20 is 40% of the total 50 seats that we have. For this number here, our fair share is going to be 30%. This is 30% multiplied by 50. That's going to give us 15 seats. Here, 20% of 50 is 10. And again, I'm using my calculator here to figure out those products. And then 10% of 50 is 5. And then again, just to double check, we get a total of 50 seats divided among these 4 states. So that seems to have worked out pretty nicely. But those population numbers were pretty unreasonable, right? It's very unlikely that the population of our state is going to be such a nice round number. So let's try it again, but with some more realistic numbers. So again, we're going to approach it the same way. We're going to compute the percentage population from each state and then multiply that percentage times, it's still 50 seats. So multiply that by 50 to figure out how many seats that state should get. So we're going to work this out in the same way that we did the previous example. So we're going to start by figuring out the percentage population. So for example, for state A, the percentage population is the population of that state, which is 83,424. divided by the total population, which this time is 213,566. So I'm going to grab my calculator and type this in. So I've got 83424 divided by 213566. I'm going to work that out to get a crazy looking decimal. So I get 0.39062397 and so on. Depending on your calculator, you might have more decimal places or fewer decimal places, but it's going to be a big, nasty looking decimal. I'm going to convert that to a percentage just like I did before. So I'm going to move my decimal point 2 spaces to the right. So I get 39 point, and I'm just going to pick the two top decimal places there. So 39.06%. Usually rounding to those 2 decimal places is plenty here. So 39.06% of the population. Let's do state B, same basic idea. The percentage population is going to be the population of that state, 67,791, divided by the total population, 213,566. So again, grab my calculator, type that in, 67791 divided by 213,566. That's going to work out to be 0.317424 and so on. So I'm going to put that into a percentage, move that decimal place 2 spaces. So I'm going to get 31.74% and so on. I can do C and D the same way. And now to figure out the fair shares, again, just like we did in the previous example, I'm going to take that percentage. So for state A, that's 0.3906, and multiply it by the total number of seats, which is 50. And that's going to work out to be 19.53. So that's the fair share for A. And then for B, same idea, take that decimal, 0.3174, multiply by the total number of seats, which is 50. That's going to work out to be 15.87. So that's the fair share for B. And I do the same thing for C and D. So here's how that works out. Now, the problem is that these fair shares are decimals, right? So what this tells me is that I should assign 19.53 seats to state A. But that's not a whole number. So how do I do that? I can't assign half a seat to a state. It has to be a whole number of seats. So the sort of intuitive thing to do would be to round, to say, okay, well, I'm going to round these to the nearest whole number. So 19.53, because it's 0.53, that's more than half. So that's going to round up to the next whole number, which is 20. 15.87, 0.87 is more than 0.5, it's more than half. So that also rounds up to 16. 10.56, 0.56 is more than half, so that rounds up to 11. And then 4.04, 0.04 is less than half, so that rounds down to 4. And again, that seems very reasonable, but now the problem is, when I add that up, that's 51 seats. And I don't have 51 seats, I only have 50 seats. So we run into a problem. So something's gone wrong here. We've done everything that it seems like we're supposed to do. We figured out the population, we followed our rule, but we don't see a way to divide up this legislature and give a whole number of seats in a fair way to each of these states. So that's where we'll stop for now, but in the next lecture we're going to consider a method to solve this problem that was developed by Alexander Hamilton. You might have heard of him, he's on the $10 bill. We're going to talk about some advantages of Hamilton's method, but we're also going to see some weird paradoxes that occur. So we'll talk about all of that in the next lecture.